Today in this lecture we will discuss the polar plot. So basically to determine the stability of a given system, there are various methods. Like we can use the Routh-Hurwitz criteria, we can use the root locus method. Similarly, we can use polar plot, Nyquist plot and Bode plot. So these are various methods by which we can calculate the stability of the system. But few methods can calculate only the absolute stability and a few methods can calculate the relative stability. Okay. Absolute stability means we can only tell whether the system is stable or not. We cannot tell the system is how much stable. So if we can give this information, the system is this much is the stability of the system. So there are some measures with the help of these measures we can tell or we can explain the system is what is the degree of stability. Okay, so these specifications or these measures are gain margin, phase margin. So with the help of these we can determine or we can explain that system is what is the degree of stability of the system. Okay, so basically Routh-Hurwitz and root locus, these are the methods by which we can calculate only the absolute stability, and polar plot, Nyquist plot and the Bode plot, these are the methods by which we can determine the relative stability. So in this lecture we will discuss about the polar plot, how we can draw the polar plot. We will do some examples. Okay, then we will see how we can determine the stability using the polar plot. Okay, so this is the aim of this lecture, right? So there are few steps. So first of all, the polar plot is the plot that we can draw between the we can plot the magnitude and angle with respect to the frequency. We will vary the frequency from 0 to infinite and we will plot the magnitude and angle. So this is the polar plot. Okay, so we will see through an examples. There are some steps that we have to follow. Okay, every time. Okay, so by using these steps, we will be able to draw the polar plot. Okay, so in polar plot, first of all, we will see. We will try to find out the open loop transfer function. Okay, sometimes it may be possible that your closed loop transfer function is given, but always try to find out the open loop transfer function. What is open loop transfer function? The open loop transfer function is GS/HS. GS is the forward path gain and HS is the feedback. So this is the open loop transfer function. And for your kind information, the closed loop transfer function is GS upon 1 plus GS/HS. This one is for negative feedback. So this is, we can say, generalized expression of closed loop transfer function. But to draw the polar plot, what we need the open loop transfer function. Okay, so first of all, always check whether this open loop transfer function is given or not. So after this, the first step is put S is equal to j omega. First we will put S is equal to j omega. Then second step we will find the magnitude. Find the magnitude. Third step is find the angle. Find the angle. And the last is, or we can say the fourth step is vary the frequency omega from 0 to infinite. Okay, vary omega from 0 to infinite and calculate magnitude and angle. Calculate magnitude and angle, and then we can sketch the polar plot easily. Okay, so we will start with simple examples. So first example, if GS/HS is 1 upon S, that is, we have one origin pole. Okay, for this we have to draw the polar plot, right? So first step will be put S is equal to j omega. So it will be g of j omega h of j omega is equal to 1 upon j omega, right? Now, second step is find the magnitude. So, magnitude of this g of j omega h of j omega, magnitude of this will be 1 upon under root real part, that is 0 square, plus imaginary part, that is j omega square. Okay. So, the magnitude will be 1 upon, sorry, imaginary part we will take only omega, not j omega. So, 1 upon omega we will have the magnitude. Similarly, we can calculate the angle. Angle will be, for this numerator part, angle will be 0 degree, and for this denominator part, angle will be 90 degree. Okay, because angle we calculate as theta is equal to tan inverse imaginary part divided by the real part. Okay, and here imaginary part is omega and real part is 0. So, omega divided by 0 will be infinite, and for tan inverse infinite we can write 90 degree. So, angle will be, we can say finally angle will be minus 90 degree. Okay. Now, this was the first step. Second step is find the magnitude. Third step is find the angle, and in fourth step we will vary omega from 0 to infinite, and we will try to find out the magnitude and angle. Okay. So, now if I put omega is equal to 0, then what is magnitude and angle? If I put omega is equal to infinite, then what is magnitude and angle? So, at omega is equal to 0, as we know, the expression of magnitude we have obtained is m is equal to 1 upon omega, and angle we have obtained minus 90 degree. So, angle we can see, angle is not depending on the omega. So, in both cases, if omega is 0 or either if omega is infinite, angle will be 90 degree or minus 90 degree. Okay. In both cases, angle will be minus 90 degree. But if you put omega is equal to 0, magnitude will be infinite, and if you put omega is equal to infinite, magnitude will be 0. Okay. So, with the help of this information, we can draw the polar plot. To draw the polar plot, we will take, this is the 0 degree axis and this is minus 90 degree, because we are moving in clockwise direction, and in clockwise direction angles are, we consider angles are negative. So, this is minus 90 degree, this one is, this axis is for minus 180 degree, and this one is for minus 270 degree. Okay. So, here we know that when this omega is 0, frequency is 0, the magnitude is infinite and angle is minus 90 degree. Okay. And similarly, when frequency is infinity, the magnitude is 0 and angle is minus 90 degree. So, in both cases, or if I change the color of this pen, in both cases, I am getting the angle is minus 90 degree. So, at omega is equal to 0, the magnitude is infinite, we can consider this is going towards infinite, and at omega is equal to infinite, the magnitude is 0. So, this point will be omega is equal to infinite, and the direction of this plot will be from lower frequency to higher frequency. So, this will be the direction of this plot. So, this is the polar plot of 1 upon s. Okay. Similarly, we will take another example. We will take another example. So, example 2 is, if I take GSHS is equal to 1 upon s square. Now, we have two origin poles. Okay. In this case, the first step will be put s is equal to j omega. So, g of j omega and h of j omega, it will be 1 upon j omega into j omega. Okay. Now, find the magnitude. Magnitude will be g of j omega, h of j omega, and magnitude will be 1 upon omega due to this and omega due to this, it will be omega square, right. Third, we can find the angle. So in previous case, we have seen that one origin pole is giving the angle of minus 90 degree. So now there are two origin poles, so angle will be minus 180 degree. Okay, so angle will be minus 180 degree, right? Again, angle is not depending on the frequency. Now in fourth step, put omega is equal to 0 and omega is equal to infinity. Find the magnitude and angle. Find magnitude and angle. So at omega is equal to 0, magnitude will be infinite, angle will be minus 180 degree. Again, when you put omega is equal to infinite, magnitude will be 0 and angle is minus 180 degree. Okay. So the polar plot for this question will be, because this axis is for 0 degree, this one is for minus 90 degree, this one is for minus 180 and this is minus 270. So the polar plot will be like this. Okay, and here we have omega is equal to 0 because it is tending to infinity, so magnitude is infinity, and here at omega is equal to infinity, magnitude is 0 and direction will be from lower frequency to higher frequency. So this will be the polar plot for 1 upon s square, right? So these two, in these two cases we have taken the origin poles. What if we take non-origin pole? Okay, so third example we will see. Third example we will see if we have non-origin pole. So if GSHS is 1 upon s plus 1. So suppose this is the given case and this is, you can see this is the non-origin pole. Okay, so the steps will be same steps we have to follow. So put s is equal to j omega. So we can find g of j omega, h of j omega will be 1 upon 1 plus j omega. Now you can find the magnitude. Second step, find the magnitude, g of j omega, h of j omega, and its magnitude will be 1 upon under root 1 plus omega square, right? Third step is find the angle of g of j omega, h of j omega. Find the angle. So for this numerator, angle will be 0 degree, and for this denominator, angle will be tan inverse omega, imaginary part divided by the real part, or final we can say tan inverse omega is the angle, right? In fourth step, what we will do, find the magnitude and frequency for omega is equal, magnitude and angle for omega is equal to 0 and infinity. So find magnitude and angle, find magnitude and angle. So if omega is equal to 0, if I put omega is equal to 0 here, then the magnitude will be 1. So in this case, magnitude is 1. And if I put omega is equal to 0 here, then the angle will be 0 degree. Angle will be 0 degree. Similarly, if I put omega is equal to infinity in this, the magnitude will be 0. And if I put omega is equal to infinity here in the angle, so it will be minus 90 degree. Minus 90 degree, because tan inverse infinity is 90 and minus sign we already have. So with this information, we have to draw the polar plot. So again, this is 0 degree axis, this is minus 90 degree axis, this one is minus 180 degree axis, and here we have minus 270 degree axis. Okay. So now we can draw the polar plot, and the polar plot for this will be like this. Here, consider this is magnitude 1 at omega is equal to 0. Here at omega is equal to infinity, we have 0 magnitude, and this is 0 degree obviously, and this one is minus 90 degree, and the direction will be from lower frequency to higher frequency. Okay, so this will be the polar plot for the given question, right? Now if we mix up these two, consider if we have origin pole and non-origin pole, then what will happen? So in next example, we will see what will happen if we have both condition, we have origin pole and non-origin pole. So fourth example we are taking GSHS is equal to 1 upon S into S plus 1, right? So for this case, first step is put S is equal to j omega. So if I put S is equal to j omega, we will have G of j omega, H of j omega is equal to 1 upon j omega into 1 plus j omega, right? Second step, find the magnitude of G of j omega, H of j omega. It will be 1 divided by omega due to this, and due to this we will have 1 plus omega square, right? In third step, find the angle of G of j omega, H of j omega. Angle, we can see for numerator part, angle will be 0 degree. Due to this origin pole, angle will be plus 90 degree, and due to this, angle will be plus tan inverse omega. Or finally, we can say angle will be minus 90 degree minus tan inverse omega, right? So this is the total angle. Now in fourth step, we will put omega is equal to 0 and omega is equal to infinity. We are going from lower to higher frequency. We will calculate magnitude and angle. We will calculate magnitude and angle. So at omega is equal to 0, what will be the magnitude? Magnitude will be infinity, right? And angle will be, if I put omega is equal to 0 here, angle will be minus 90 degree, right? Similarly, if I put omega is equal to infinity here, then the magnitude will be 0, and if I put omega is equal to infinity here, then the angle will be minus 180 degree. So with this information, we have to draw the polar plot. Again, we have this axis for 0 degree, minus 90 degree, minus 180 degree, and minus 270 degree. So to draw the polar plot, so polar plot will be like this. Okay, so this one is for omega is equal to 0. Here at omega is equal to infinity, magnitude is 0. Okay, and the direction will be from lower frequency to higher frequency. So this will be the polar plot for the given question. Okay, so these are some examples to draw the polar plot, right? We can add one more non-zero pole to this example. So next case we can take, GSHS is equal to 1 upon S into S plus 1 into S plus 2, right? So first step will be put S is equal to j omega, right? So after putting this, we will have G of j omega and H of j omega. It will be 1 upon j omega, 1 plus j omega and 2 plus j omega, right? We can find the magnitude of G of j omega, H of j omega. We can write 1 divided by omega into under root 1 plus omega square under root 4 plus omega square, right? This will be the magnitude. In next step, we can calculate the angle of G of j omega, H of j omega. Angle will be, due to this numerator part, angle will be 0 degree, and due to this denominator part, it will be 90 degree. Due to this origin pole, again tan inverse omega. Due to this non-origin pole, again tan inverse omega divided by 2, or we can write it as minus 90 degree minus tan inverse omega minus tan inverse omega by 2, right? So if I put in next step, if I put omega is equal to 0 and omega is equal to infinity, we can calculate the value of magnitude and angle. Magnitude and angle. So at omega is equal to 0, you can see from here omega is equal to 0, the magnitude will be infinity. For omega is equal to 0, this will be 0, this will be 0, angle will be minus 90 degree, right. When omega is equal to infinite, magnitude will be 0, and for omega is equal to infinite, this will be 90, this will be 90, and total angle will be minus 270 degree. Minus 270 degree. So the polar plot will be, we can draw in the next slide, polar plot will be like this. This is for 0 degree, minus 90 degree, minus 180 degree, minus 270 degree, and the polar plot will be like this. This for omega is equal to 0, this point is for omega is equal to infinity, and the direction will be from lower to higher frequency. So this will be the polar plot for the given question. Okay. Now we have done 4 to 5 examples. Now we will see how we can determine the stability using the polar plot. So this is the best example to show to calculate the stability of the system. Okay. So we are defining the two terms. One is phase crossover frequency. Phase crossover frequency. Phase crossover frequency, that is omega PC. Second is gain crossover frequency, that is omega GC. Okay. What is phase crossover frequency? When the polar plot is intersecting with the minus 180 degree axis. So this point, at this point, the frequency will be called omega PC or phase crossover frequency. Okay. And if I draw a unit circle, so for example, this is a unit circle. The polar plot is intersecting with this unit circle. The frequency at which it is happening, it is called omega GC or gain crossover frequency. Okay. Obviously, at phase crossover frequency, the phase angle will be minus 180 degree, and at omega GC, the magnitude of this will be 1. Okay, because we are drawing a unity circle, so the magnitude at omega GC will be 1. So we can calculate omega PC and omega GC. Then how we can explain or how we can determine the stability of the system, right? So now we have two terms, omega GC and omega PC. Okay, so there are several conditions. If omega GC is less than omega PC, in that case the system will be a stable system. If omega GC is greater than omega PC, then the system will be unstable system. And if both are equal, omega GC is equal to omega PC, then the system will be called marginally stable system, right? So for these three conditions, we can draw the different plots, polar plots. For first condition, the polar plot will be like this. That is omega GC is less than omega PC. Okay, that means the unit circle is intersecting the plot. Unit circle is intersecting here. So this is omega GC and this frequency is omega PC, right? So in this case, omega GC will be lower than omega PC. So this is the example of stable system. Second case will be if omega GC is greater than omega PC. So this is this case. That means if this magnitude is higher than 1, which magnitude? This magnitude, if it is higher than 1, in that case the unit circle is intersecting it here. So this frequency will be omega GC and this frequency will be omega pc, and in this case you can see omega gc is higher than omega pc. So this is the second case, that is the unstable system. This is for stable, this one is for unstable system, right? And third case is if unit circle is here. So here both frequencies omega pc and omega gc are lying at this point. So this is the case of the marginally stable system, right? So to calculate omega pc, what we can do, we can put angle is equal to minus 180 degree. As in the last case, the final angle we are getting, it was minus 90 degree, minus tan inverse omega, and minus tan inverse omega by 2. So this angle we are getting. So we will put this angle is equal to minus 180 degree. So if I put minus 180 degree is equal to minus 90 degree, minus I can take common, I can write tan inverse omega plus tan inverse omega by 2. So it will be minus 90, or minus will be cancelled out. So 90 degree is equal to, I can use apply the formula here. So it will be omega plus omega by 2 divided by 1 minus omega square divided by 2, right? And it will be infinity is equal to omega plus omega by 2 divided by 1 minus omega square by 2. So it will possible only when 1 minus omega square by 2 is equal to 0, or from here we can calculate the value of omega. So it will be omega is equal to under root 2. Okay, under root 2 radian per second. So this omega is nothing but omega pc, phase crossover frequency, right? Similarly, if I put magnitude is equal to 1, then the frequency at which it is happening, it is called the gain crossover frequency. So it is very easy to find these frequencies, and with the help of these frequencies we can tell about the stability of the system. Although in 99% cases these are this method is valid, but there are 1% cases in which this method is not we can apply, right? For those type of questions, we find the gain margin and phase margin. Okay, so with the help of gain margin and phase margin, then we can tell the stability of the system, right? So this is the we can say how we can draw the polar plot in this lecture we have seen, right? So we will stop it here. Thank you.